This lesson is on balancing chemical equations. It corresponds to Roman numeral 2 in your notes packet. Here we have a picture of an unbalanced scale. The aluminum chloride in this skeleton equation has more atoms in it than the product side, aluminum plus diatomic chlorine. But according to the law of conservation of matter, matter can neither be created nor destroyed. Therefore, a balanced chemical equation has the same amount of each type of atom on both sides of the yield sign. When we have a balanced equation, things are balanced out. Letter B, equations are balanced by changing the coefficient, which is a number that is placed in front of the chemical symbol. It's like in algebra class when you put a coefficient in front of a variable like x or y. Here are some examples of coefficients in chemistry. If I put a 2 in front of a chemical compound like sodium bromide, instead of there just being one sodium and one bromine, I've actually got 2 sodiums and 2 bromines. In front of calcium chloride, I started off with just 1 calcium because there's no subscript, and 2 chlorines indicated by the subscript. When I put a coefficient like 3 in front of it, that actually gives me 3 calciums and 6 chlorines because I've got Cl2 3 times, so that would be 6 chlorines on that one. Let's look at some examples of full equations. In this equation, calcium oxide is broken down into calcium plus oxygen. The first thing that I want to do in balancing an equation is to make a list of each type of atom in the equation and count how many of each I have. In this case, my 2 elements are calcium and oxygen. On the reactant side, I have 1 of each, and on the product side, I have 1 calcium, but I have 2 oxygens. I want to make those numbers equal. I want to make, if calcium's on this side 1 and this side 1, they're already equal. However, my oxygen on this side is 1, and my oxygen on this side is 2. Since they're not equal, I need to use a coefficient to equal them out. That coefficient is going to go in front of this side, whatever substance my oxygen's a part of, which in this case is a compound. So I need to multiply by 2. Coefficients are always multiples. And if I put a 2 in front of calcium oxide, that means that I'm actually multiplying my number of calcium and my number of oxygen atoms both by 2. So I can change my counts to 2 calciums, 2 oxygens. Now, calcium was balanced, but now it's not. Can you think of how you could balance the calcium? On the product side, if I put a 2 coefficient in front of the calcium, now I can say I've got 2 calciums on this side as well. Now, calcium, 2, 2, oxygen, 2, 2, everything's balanced out. It's just a coincidence that both calcium and oxygen's numbers are 2. That's not what's important. But what's important is calcium has to have the same number on both sides, and oxygen has to have the same number on both sides. Here's our next example. Aluminum chloride yields aluminum plus chlorine. If you want, pause and do your own list and count. You should have said aluminum and chlorine, 1 and 3 on the reactant, 1 and 2 on the product. Aluminum's already balanced. Now, chlorine is 3 and 2. We have to find something that they both can go into evenly. Of course, we know they can go into 6. So I need to make each of these a 6. I'm going to start on this side. To get 6, I have to multiply 3 by 2. So where am I going to put that 2? In front of the aluminum, because aluminum chloride is a compound. That means now that I've changed chlorine to 6, but I've also changed aluminum to 2. Okay, now let's think about the other side. There's 2 chlorines on that side. Well, to get 6, I need to multiply by 3, and that gives me 6 chlorines. This time, I don't have to change my count of aluminums. That aluminum is separate from that chlorine, so it only really changed the chlorine. Aluminum does have to change now, though, I have 2 on the other side, so I need to get 2 on the product side as well. Just put a 2 in front of the Al, and we're good to go. Number 3 has a polyatomic ion in it. Whenever you have a polyatomic ion, it's wise to go ahead and count that polyatomic ion separately. So what I basically have is calcium, just 1, perchlorate, 2, sodium, 1, and fluoride, 1. On the product side, notice that even though it goes calcium and then fluorine, I just put the fluorine at the end and use the exact same order as I did on the reactant side. Just makes it easier for me to keep track. Something like perchlorate might not always be in parentheses. I put it in it here just to show you that it perchlorates on both sides, but you need to just get familiar with remembering to look at both sides to see if you have any polyatomic ions in common. Of course, our counts are 1, 1, and 2 on the product side. If you want, pause here and try to finish it up without me. So what I decided was to balance my sodiums first. Sodium was balanced to the perchlorate. I put a 2 over here, and that changed sodium as well as perchlorate. So I have 2 perchlorates and 2 sodiums right now. Then I had to fix sodium on the other side, so I put a 2 here, and that also changed fluorine along with it. Now calcium's 1 on each side, perchlorate is 2 on each side, sodium is 2 on each side, and fluorine is 2 on each side. So it is all balanced out now. We're not going to do the 4th example just yet. We'll do it tomorrow in class because it's a little more complex. In the meantime, I want you to try these problems from the book on your own. Bring them to class tomorrow and we'll go over them.